of renewable energy, then actually we can conduct this session as the discussion level. Then the basic concept of renewable energy and what are the challenges and how we can use renewable energy as well as some historical usage of energy for previous civilizations. Okay, that there are 3 sessions need to be covered. Actually, if you go to that course Moodle pages, then materials are already uploaded to the system. You can visit this material and learn up to lesson 3. And, basically, lesson 1, those are the learning outcomes. There's a fossil fuel description and what are the understand between the fossil fuel energy and renewable energy. Then explain why the fossil fuel and renewable energy are at the center of attention, as well as some environmental impact. Then again, skills to a certain importance of renewable energy as well as the fossil fuel transition. Now, yes, first we learn what is the fossil fuel. Actually, fossil fuel, we know that present day we are hugely use that fossil fuel our day-to-day energy requirement to fulfill our requirement. Then actually the basic advantage of the fossil fuel are very much high. That's the reason it is very much popular and people are very much promoted to use the fossil fuel. The main thing is the very high energy density that is important for as a fuel, because of that the fuel in the fuel it is very high energy density, that especially for transportations and everything it is much more useful. Then other thing, maybe the cost of energy also very much important factor. I'll explain that why that renewable energy abundant due to that the fossil fuel come to the world. Then actually based on this there are 2 concepts in the world, why that the fossil fuels in the world here. Then we know that the why its name wise the fossil mean the long time ago there are many the plants and animals in the world. Then after that it converted to the hydrocarbon, especially the carbon based material. Then after the long time under the earth it compressed and converted to the some sort of carbones. Then this after the millions of years that reactions without oxygen media then is converted to the some sort of the fuel, maybe the coal or the liquid wise the fuel based one. Then actually this fuel main basically a long time ago it's converted to solar energy by the photosynthesis, then it's converted to that type of the carbon base the fuel there. There are some other concepts also there. It's not the fossil, it's automatically that is come already in as a mineral. Then that also one concept. Then we are not going to discuss up to that level. However, then how presently the fossil fuels are we can achieve. Then those are the fossil fuel. However, this fossil fuel, the fuel need to be the burn with oxygen. There's a chemical reactions. Then after we can burn that fuel, we can generate thermal energy. That's the basic point there. Then the thermal energy is the energy point of view, the thermal energy. Thermal energy can be converted to the other source of energy. Yeah, there's a way how we can use that fossil fuel. Then we know that these technologies, then after combustion, that means burning, then other all the impact to the environment as well as other what are the substance as the carbon dioxide emissions and all already there. However, now we give some sort of what are the renewable energy. That renewable energy is, there's a comparison of the fossil fuel and renewable energy. The fossil fuel, we know that what are the fossil fuel based on. Now, renewable energy is the natural resources. We have a lot of natural resources. Then these natural resources, we can convert it into energy, the form of energy. We know that there's some idea that then here we can discuss in a very detail what are the technologies as well as what are the other concept of that conversions. We know that solar and the solar is the main source, actually. The main energy is come to the world as a solar. Then the solar conversion, also we can think about that, how we can solar energy convert to the useful form of energy, as well as a hydro and geothermal, the wind and the tidal and biomass. Then there are few type of the source of renewable energy, but that is tidal, the wave and other other source of other type of technologies are there. Now we see now actually meaning of that renewable energy, the concept of that renewable energy is renewable. Renewable mean it not exhausted. Then it can be continuous of supply because resources are available naturally. Then that's the point of the renewable energy. We can think about the resources are freely available. Freely available. That's the point of there. Then that not like the fossil fuel. The fuel need to be not freely available. Then, however, if these resources are already in the environment, this only point is the harness of renewable energy. Then here, the concept is not basically it's the virtual is not there is an inexhaustible. However, then actually the driven for renewable energy, there are many factors present day we can think about that. Actually, dependency of the fossil fuel also very much the critical factor, especially country like us, because of we have not the fossil fuel, especially there are foreign currency is involvement there, as well as other lot of other situation, maybe environmental as well as maybe the energy security, lot of things need to be considered. Then actually, this is the thing and the present day we can think about as well as the as a internationally also presently we have some goals there because of the effect of that the fossil fuel burning is huge now, especially it is some assessments are there because of the global warming and other things also need to be considered up to some level because of the carbon emissions also try to mitigate up to some level. Then at that point, then renewable energy conversions are important in this point. Now, we'll see how. Yeah, actually, there are some type of the renewable energy sources as a technical concept because of the already resources are there, the energy also there because of especially the energy, the form of energy. We know that maybe potential energy, maybe kinetic energy, maybe thermal energy. Though those are the energy, the type of energy. Then the technology need to be developed to convert these type of energy to useful manner. If we have the thermal energy, yes, sometimes if we requirement, actually our requirement of energy, so we require the thermal energy, yes, obviously, because of thermal energy requirement is there, as well as the electricity and mechanical energy and also light. Then those are the required the source of energy, our day-to-day life. Then there are the technologies here in the name wise, the hydroelectric power. That means hydro can be converted to the electric power, then as well as the wave energy, and then the tidal energy, solar energy, biomass, geothermal, and wind energy. You can see here, there are a large amount of the technologies available when we consider renewable energy point of view. However, presently, some of these the technologies are not primitive as well as not commercially available. We can discuss those are the reasons, even though resources are there, huge resources are there. Why we cannot harness some sort of energy? Because of this energy is a different concept. It's always the bind with the economy, then socio-economy, and those things combined with the energy. Now, I hope these are the basic concept we all know about that. We can little bit go deeply. Now, if we this is little bit all side with the world energy consumption. However, that consumption wise now it's much bigger compared to the 1995. However, we know that the main energy creator is a solar. The solar energy come to the world. Then this is a main source of energy. Then solar energy is converted to the other all source of energy, except nuclear and geothermal. Then because geothermal and nuclear is not maybe the source of the solar, it's originally from other way. We are not going to discuss deeply those things. However, if we think about that other source of energy like the hydropower, biomass, and the sea wave also, yes, obviously, those are the source of energy, the wind energy also, basically due to the solar energy. The solar energy converted to the other source of energy. You can see here. If you think the amount of solar energy received to the world is a huge amount. I am not going to read these numbers. There is a 10 to the power of the 13 kilowatt hours into the huge amount of there. Then you can see in the scale wise, this is the scale wise presentation. You can identify how much that energy is converted to the wind energy. That converted in energy as well as it's converted to the energy source of the wave and sea energy. Then the biomass as well as the hydropower. You can see here, those are the concept of the source of energy as well as the required, the world consumption also there. But we know that even though the energy is available, we cannot utilize this all energy due to some other lot of reasons, maybe technology, maybe other things. However, there is energy. There is a large amount. There's a huge amount of energy. This is the source of renewable energy out of fossil fuel. You can see here. There are no any fossil fuel. Then, if the scale wise, we can say that yes, total energy requirement of the world we can fulfill by renewable energy. Yes, obviously. However, then there are things are there we can discuss. Maybe technology may be still not developed up to that level. Maybe some other reasons. Right. I think further to that, if somebody need to clarify something, no problem. You can disturb me at any time. You can ask any questions at any point. Then I would like to contribute to your knowledge also. I hope these are the basic knowledge who everyone know up to some level. Then you also can contribute, no problem, right? Yes. This is the somewhat slide what I found from the some site. The reference is there. You can see here in our human civilizations, we require energy, our day-to-day life. Then there's a basic the requirement for our day-to-day life. You can see here. However, then this is a fossil fuel era. Presently, we are living in the fossil fuel era, but the civilization may be not into that only that era. There is a before that as well as then we have to think about the after that. Then this fossil fuel time is very small compared to the range of our human that live in this world here. You can see here. Now actually we are almost in the just after the peak point. Then it estimated there. Then after the 3000s year, then we need to finish our fossil fuel. Yeah? Then we have to think about some other source of energy. You can see here. Then compared to the whole period, you can see here we need to fulfill our energy requirement is renewables. The fossil fuel is small, the period of the total span there. Then, however, now the thing is that now we adapted to all this energy requirement, the fossil fuel. The present day, the challenge is again renewables. You can see here, previously we used renewables. Previously we used renewables. Wait, yes. Previously, we used renewables to fulfill our requirement. Then it's changed to the fossil fuel. The present day, the main energy supplies of fossil fuel. Then after we need to think about that again, we need to convert to renewables. Then this is the transition. We are calling this the energy transition. Renewable to the fossil fuel, then fossil fuel to renewables. Then those are the transition of energy. Then engineers have a lot of the work to this transition period, as well as renewable to fossil fuel also. They did a lot of technology development to how we consume fossil fuel to fulfill our requirement, as well as the present day. Also, we are thinking about then develop new technologies as well as other concepts, how the energy transition, the fossil fuel to renewables. Right. Now, that's the point here. Now, the present day we are thinking about that how we can develop technologies for this energy transition in the present day. Maybe a few years back, the 50 or 100 years back, so people are thinking to how we convert to renewable to fossil fuel. Yeah, this is some concept-wise one. I'm here in these first sessions. We are not going to discuss very deeply in the technology-wise. This is direct conversion. We know that the solar, I already explained there, we receive solar energy. That is the original source of energy come to the world. If we can convert as it is to useful manner, it is good. You can see here, this is a mechanism, the solar cell. The solar cell is the primary conversion technology. It can be directly converted to the solar energy to electricity. We know that, I hope you have some idea about the exergy values. The meaning of the exergy means the quality of energy. Then the quality of energy, there's a conversion possibility. We know that if we convert the thermal energy to electricity, there are some constraints are there. Then we cannot convert 100% thermal energy to electricity because of some thermodynamic constraint are there. Then there's Otto cycle. There's a thermodynamic cycles conversion constraint are there. Then but in the exergy wise, if we have electricity, that electricity can be converted to the mechanical energy or thermal energy with high conversion efficiency. Then I'm not going to explain much about the thermodynamics here. However, then exergy wise, that the highest exergy has a electricity, then there's a mechanical energy and thermal energy. Then if the solar energy converted to electrical energy, it's good point because of the conversion is somewhat good. However, we can see here solar to that conversion may be much less conversion efficiency if it's the thermal is there. However, there's semiconductor devices is using here. This is the technology. That technology is converted directly, that is solar energy. As well as you can see the wind energy also there. The wind energy, wind is again coming from, the wind is generated due to, again, the solar energy. We know that the wind blow due to pressure difference across the world. That pressure difference are due to the temperature differences across the world, as well as the directions and everything depend on the effect from the Earth rotations. Then the wind is blowing. Now the wind has a kinetic energy. Wind has a kinetic energy because of the wind is a sort of mass there. The mass is moving around the world. Then this kinetic energy can be converted by using wind rotors. This kinetic energy converted to wind rotor, the useful energy, kinetic energy converted to mechanical energy. Mechanical energy can be converted here. Then this is the one concept. It's a useful concept. Actually, this is very much a promising technology in the present day. They hugely use around the world is a competitive technology compared to other source of energy. Then here, there's a wind energy one. We can discuss later what are the technology behind there. As well as other one is a very old technology, is a hydropower. It's hydropower. Also, you can see here the rainfall. The rainfall from the high elevations, then automatically there's a potential energy. The wind we are using kinetic energy. Here there's a hydropower. We can use here the potential energy. This potential energy can be converted to the useful manner. We know that if we have the mass in the high elevation, if bring down, that potential energy can be converted to the kinetic energy, then the kinetic energy can be converted to the mechanical energy. This is the energy conversion is there, the technology. Actually, technology can be developed with the highest conversion efficiency. That is point of view. Yes, generally, if we think about that, because of the efficiency is the main point here. Sometimes it's depend again. If we think about the renewable energy, sometimes it's a one factor. Yes, obviously that is the conversion efficiency is the one factor, but the important point is the cost of energy wise. I'll explain that. Why? Because of the source of energy is free, then the cost of energy is an important point here. However, that is the concept-wise how that hydropower is coming here. Actually, there are two type of technologies for a large hydro as well as the small hydro. Then the concept-wise almost same, but the technological lot of civil constructions and everything are huge difference in a large and large and small. Now, the biomass. The biomass also we can think as that also renewable energy because of it's a carbon neutral. The carbon neutral. Why it is carbon neutral point of view? The carbon neutral mean the biomass is converted to the solar energy by the photosynthesis to the carbon. It's the chemical conversions. Solar energy converted to the chemical conversion. It's a chemical storage again. Because of that, then the carbon is absorbed from the environment. It converted to the hydrocarbon. That's the biomass. The heat here. Then this biomass can be used to generate energy. It can emit carbon there. Then, however, the cycle-wise, we can consider it's a carbon neutral fuel. That is environmental friendly because of it. Yes, environmental friendly mean the cycle-wise is not carbon emission. Each and every technology we have a lot of environmental impact. Then we can discuss these things sometime. Sometime you can see here the comparatively some hydro may be the huge environmental impact. Like then we have to think about that later. However, the biomass also we can consider as a renewable energy because of carbon neutral point of view. Now, there's examples of that the biomass, obviously tree, grasses, seaweed, and those are the things, as well as the waste is coming from agriculture, as well as sometimes municipal waste also we can consider as a biomass. Then those are the point of view. Then actually the energy grow concept is there. We can grow separate the plantations for energy. Then that also concept as a biomass. Actually, biomass wise in a country like us very much important. Actually, biomass is not the new source of energy. The people are use that biomass for the long time for to fulfill their energy requirement. Now, the technology, the concept you can see here, there are two types of concept we can use to the biomass, especially for a direct combustion, as well as we can, so the gasifications, those are the concept by those things. However, there are usage-wise, it is huge, widely. We know that the present day also in Sri Lanka, we are using biomass to fulfill our industrial thermal requirement. We know that our is the huge industry, thermal energy requirement industry, tea industry, almost 90% of thermal requirement of the tea industry fulfilled by the biomass. There is a good point. We are using large amount of the biomass steam boilers for thermal to fulfill our thermal requirement for industries here, right? And actually, here I'm not going to discuss these things in detail. However, the concept-wise, the two methods, combustion and gasification. Gasification, actually combustion, we can direct combustion biomass and generate thermal energy. Then it's a controlled combustion. Obviously, we need to develop technologies to the low emissions. Then those are the technologies are there. Then we need to achieve the temperature as well as the low emissions. Gasification also another technology. Then gasification mean without the less oxygen, we can generate produce a gas. Then here this technology we can reduce much amount of other emissions. Then these producer gas can be used as a fuel, yeah, as well as the byproduct also can be generated, maybe a biochar and other sorts of things, maybe bio oil, and those things can be generated by that method. This depends on the requirement sometimes. Yes. Then basically we are going to discuss about the biomass conversions as well as the hydro, solar, and wind energy. Those are the most primitive conversion technologies we are going to discuss there because of due to some reason, because of maybe it's commercially already available, these type of technologies, as well as solar thermal also there. However, the geothermal power, tidal, and octake are also renewable energy, source of renewable energy. Then we can think about to use this type of things later. However, presently, these, especially the geothermal, tidal, and octakes are not much popular in the world due to maybe some other reasons. Actually, those things are very much site specific, as well as the cost of energy, the point of the cost of energy generation. Then site specific in some sites it can generate the energy at somewhat lower cost, but some sites is much higher. As well as the wave energy also they are here. In the concept wise, the solar heating, yes, that is also very much a popular technology. We can use the solar thermal collectors are here. Then here in the world, we are using for thermal. Actually, we require thermal energy. Our day-to-day life, maybe the cooking, maybe for the space heating, maybe other heat sources in a household application. Obviously, some when we consider in the industrial scale, yes, we require large amount of thermal energy requirement. Then this thermal energy requirement can be fulfilled by the solar solar energy. However, you can see some technologies are there on the flat plate collectors as well as the equivalent tubes collectors and the concentration solar, maybe parabolic as well as the tube type also there. Then there are these are the technologies to the solar collectors to generate thermal energy. As well as we can see here that those are the some sort of household system. Um, Solar siphon we are collecting there. There's a storage tank there. Then the water can be heated up to some level. Then the hot water requirement can be fulfilled by these type of collectors here, as well as direct as well as the indirect systems are there. Some countries they can use as a space heating as well as a space cooling. Also, we can use thermal energy if we go for an absorption refrigeration cycles. Ocean energy wise, this is also very much a site specific one. Uh, there is a temperature difference in the ocean, the high temperature and low temperature. Some places we notice that high temperature in the deep sea as well as some places high temperature in the surface level. That's depend on the location to location. This temperature difference can be used to drive a turbine there because of the turbine, the closed loops turbine cycle can be operated due to that temperature difference. Then it can be used to turbine and generate electricity by using this type of the temperature difference in the ocean. Then we are calling the octet one. Octet one, we can see the one concept in some places the 26 Celsius as well as the 5 degrees Celsius. Even though such a temperature difference, if we use the working fluid there, we can generate energy. We know that the large amount of thermal energy may be in the sea, even though at a low temperature difference. Yes, other one we know that there's a tidal wave. Actually, tidal also we can consider as a renewable energy, but it's not coming from that sun, solar. There's a gravity. That is, the tidal is generated due to the interaction between the gravity of Earth and Moon. Then the two tidals are coming to the Earth and each and every day. Then the sea levels are varied due to that tidal. Then sea level difference can be used to generate power by using turbines. But the height of the tidal is depend on location to location. We know the Sri Lanka, we have not much tide here, but some countries, some locations, they may have the huge tide there in few meters, as well as the location of the places. The tidal also can be used. This is tidal wave generations are also highly site specific. Then it can be also utilized the place to place. Here. The other one, yes, there are the concept-wise. In the tidal wave concept-wise, there are the few concept maybe there, as well as the wave energy concept also. With the wave also there, then we know the sea wave also. The level of that the sea level is changed in quickly in the wave generation. The wave power also can be converted to the useful one by using maybe buoyant. The buoy also can be used here as well as some air chamber. There are different technologies depending on locations as well as maybe the cost wise also. The geothermal one also the popular in some countries because of the temperature difference in the under the earth, the high temperature difference because of the high temperature in the underground. Then the water can be used there and generate steam sometime, maybe some hot water or steam. Then we are calling this a geothermal one, that the thermal energy inside that earth can be used to generate energy here. Then the geothermal sub-countries, they have, especially the volcanic activated countries, they have that type of energy. Then it also can be considered as a renewable energy. But the country like Sri Lanka, we also have some resources, but technical viabilities is still we need to discuss about that. There is a comparison of these technologies. this comparison of these technologies, we can compare, especially these are the sort of renewable energy: solar, wind, hydro, biomass, geothermal, and ocean. You can see here, in the application wise, yes, very much simple. In the solar is very much simple. It can be converted directly to the useful manner, as well as the thermal energy also can be fulfilled by the solar. Then we can say the passive system. So active system, both systems are there. Then the passive systems are very much comfortable for small scale one. Then, this is the very much commercially available uh, technology. Here, that the capacity factor wise, yes, some challenges are there because of the solar is available in the limited time of the day. Then, as well as is intermittency also very much huge because of the cloud cover and other factors can be effected to change that the solar radiation sources. Then this capacity factor, it can say around 10 to 30%. Actually, this capacity factor mean if we have some capacity of the plant, if it is work that plant its full capacity throughout the day, then the ratio between the actual generation we are calling the capacity factor. But the actual generation is much less than if that the plant is working its full capacity over the day. Then this ratio is a capacity factor. You can see here. Now is solar as a 10 to 30%. You can see here that the wind also the somewhat low capacity factor. That the wind and solar, the both this capacity factors depend into the location because of this depend on the site specific. Then those are the commercially available one. Then you can see the solar, wind, and hydro very much commercially available resources in the present day. Is a highly use these things. Now, actually, in the wind also, that issues is there, the less capacity factor. But I noticed that some places in Sri Lanka, we have that capacity factor rate maybe over 40%. That is a good point. Then, actually, compared to the large hydro, it is can be fulfilled by the base load. You can see in the base load and embedded load, there's embedded generation and the primary generation wise, the hydro can be used as the primary generation, but unfortunately solar and wind can be considered as an embedded generation. Now the present day, that also a huge challenge in the world, how we can use these solar and wind as an embedded power. Yes, now those are the three main categories. Yes, biomass also there. Actually, biomass has the different technologies. We know that the combustion as a fermentation, so we can convert it into some other source of energy, maybe alcohol and other things as a fuel. Then bio oil as well as the gas, oil, gas, as well as the fermentation wise, the biological pathway, the biomass converted to the biological pathway, the useful product. We are calling fermentation. And the last two one, liquefaction and the gasification, we are calling as a pyrolysis process. The pyrolysis mean here the biomass can be the thermally crack without oxygen media or partially with less oxygen media. We are calling the pyrolysis. The pyrolysis, it consumes some energy. However, it can be converted to useful product like as the bio oil or gas, as well as the biochar, also some other product also there. Then it's a biomass. It has different technologies with the different type of fuel because of the biomass. Maybe pellets, maybe logs, maybe that's depend on the quality, maybe the moisture content. A lot of variations are there, not like solar and wind. Then again, the main point here that also again the seasonal wise, then the biomass also in the coming from the environment. Then again, it need to be consider some challenges like the deforestations, and it can be also useful to the waste management as well as the use of the agricultural waste there. Now, these four are the the main source of energy. In your course, we are going to deep discuss the solar, wind, and hydro biomass. But we are not much discuss about the geothermal, object, the wave, and the tidal, and those things, because of those are the very much the site specific, and is still not much of the commercially popular in the world. There are a lot of researches going on still, how we can reduce the cost of energy wise, as well as other improvements. And this also a comparison of that renewable energy point of view. Then I hope you all know about that the payback periods, no? The payback periods in the money wise, the financial wise. The payback period mean if we spend some money, if we invest some money for any type of the project, the return, what's the time period to return back that money, we are calling the payback period. Similar way, in the energy also we can consider the energy payback period. That means energy payback period also we need to think again, because of the present day we always talking about the life cycle assessment and everything, because of that the circular economy point of view. Here, that how much of energy we required at the production stage, that also important point. Then that energy, what it consume at that initial stage, up to that is commission the plant. Then that energy, that consume energy, used energy to that plant, what's the time period to generate that same energy, we are calling the energy payback period. Now, that is the point here. If we think about that, some sort of energy sources are there, the coal, nuclear, the gas, and the large hydro. You can see here the coal is the least, the coal and gas are the very much the least energy payback period point of here. The gas can be, it can be generated, the energy it consume around the 0.4 year, the months, no, the months. They can see here. Then it's a coal also within the short period it can fulfill. The large hydro also 5 to 6 months. Then because of actually we can, why this energy consumed for large hydro? Yes, it's maybe transportations, maybe cement productions, everything. If you go for a life cycle assessment by the energy point of view, some amount of energy we required there. Actually, most of the time that energy fulfilled by the fossil fuel. You know that at the initial energy we fulfill by the fossil fuel because of the low cost energy here, especially transportations and production scale. That also need to be assessed very carefully. If we go for a in detail assessment, we can think about that, what amount of renewable energy use at that point of before commissioning. Here that a micro hydro, small hydro, the wind, and the solar is there. Actually, solar is the bad, very much the worst point of view. You can see here. Sometimes the 72 to 93 months. That mean more. Sometimes it's more, almost 5 to 10 years sometime, because of what it consume energy at its production time, it generate this much of it required this much of time to generate the same energy. But in the present day, we are using the thin film technology. Thin film technology is much more better compared to these technologies. These are the old technologies. Thin film technologies that the energy payback period is much less. How you can see it in other point of view, sulfur emission, NOx, and carbon dioxide. Those are the because of if we compare to renewable energy and fossil fuel, we also think about that. What are the amount of emissions there? Then in the solar is the worst here again, because of it may require large amount of energy at its production stage. It emit a lot of sulfur, NOx, and carbon dioxide at its production stage. As well as it required that huge amount of time to generate same amount of energy we did consume at the production stage. Yes, this also we need to think, consider. Actually, presently, life cycle assessment mean these all factors we have to consider. Uh, if we go for if we assess proper assessment comparison with the source of energy. Yes, again, actually the concept-wise renewable energy, was a brief view of the renewable energy, positive and negative, all these things we have to think about that. Then, actually we know that the very first slides I explained that we converted to renewable to fossil fuel. No, then, these things we can discuss. However, then this is the context of the historical concept of renewable energy is the one lesson you have there, because we need to understand that, the historical the history we use renewable energy. Actually, we know that the technology is developed always with the requirement of the society. That's my point here. Because of if society is required anything, the people always try to fulfill that requirement. The technology is also need to be developed to fulfill that requirement. Because of we know that maybe 1,000 years back, maybe the 5 years, maybe the 5,000 years back, brain power of that humans is same as today, right? It's not changed now, because of the brain power is same as today. The capacity, the brain capacity and ability in the present human, it not much difference, because of they also have the same capacity, the same ability to develop technologies with the availability of that time. There's the presently also we are develop our technologies. What are the available resources? What we required? Maybe the requirement also change time to time. Okay, see here. Yes, in energy requirement. This energy requirement is again is a huge challenge there. Then we cannot understand sometime. Then we can think about that, why that energy requirement of that human being. You can see the historical technology concept of the harness renewable energy. We can little bit discuss these things. You can see here. Historical renewable energy requirement, actually, the basic requirement of the people is food as well as the transportation. Maybe those are the main point. Maybe the comfort, the living conditions, right? Those are the things. The food is the main requirement. The drying and smoking, those are the required. Personally, we are using solar. Personally, we are using renewable energy for the food preservations. It's a long time ago also that people use biomass as well as a solar. Those are the things. It's not much things to discuss here. Just take your idea about that. The source of renewable energy we use as it is today also, as well as at that time. But in the food preparations, again, very much important. Okay, see the one technology that is the common technology we are using for food preparations, the grinding grains, the flour. Actually, I hope you know that we have this equipment in village house there. Then the same technology uh, can be converted to some for large scale productions, maybe converted to the operated by windmill or water wheel. That was there in the long time ago. That is around the world. Actually, you can see here This is the concept used in the world, the same technology, same as the Kukurahangala technology. The two stones are there. We are using the top stone and the bottom stone, the bed stone. Then that can be the powered by other source of energy, maybe the hydropower, maybe a wind energy. There's a grinding mill is using because of generating the food preparations one. Then previously they used the windmill. The windmill is coming that technology. The water mill also coming that technology. The water energy, that means there's a potential energy in the water or kinetic energy in the water converted to the wheel, and mechanical energy was directly used to operate that the stone for food preparations, as well as maybe the oil. There's maybe that oil speller also using the same technology. You can see here that also considered as renewable energy usage. This is the windmill. The mill is there. The mill mean the grinding. There's a grinding one. The mill name is coming there. The mill is for grinding grains. Then this was the technology used for, especially for Europe, because of the food pattern is different. They use a lot of the flour for they need to preparation of that the grain in the flour. Then as a windmill was used there at that time. The mill, that was a culture. The mill, windmill smith also there. This is a culture. Then here in a village, each and every villages they have that type of mills. Then village requirement of the food preparations, they use this technology. If you already visited Europe, maybe still some type of mills is already there in some places. It's still personally it's not working. However, the present days they use that type of things. There's a usage of renewable energy. But in Sri Lanka, we not use that the windmill technology for food preparations. We have the different kind of culture here. Yes, that is the concept regarding some sort of concept we use as the renewable energy. Now, here some of the transportation wise. The transportations wise also we use renewable energies. The sailors use that is a technology you can see here, sailors. It's not the present days, maybe 5,000 years back, maybe 7,000 years long. For a long time, people use for sailing that of wind energy. There's some evidence also there. There's one evidence we can see here that I found some evidence. There's a shipwreck site in near the Sri Lanka. There's a Udavaya harbor. There's a mouth of the Walave River. Actually, this is the 2nd century of before BEC. Then that was a one evidence. Obviously, there are a lot of this type of things around the world, not only Sri Lanka. Then the wind energy is used for transportations. And when these ships are sailing around the world at that time, maybe 5,000 years back, maybe 3,000 years back, the technology was there because of, I already explained that technology was developed, the requirement of the society. Now, those are the historical one. Other point of view, then because of that also technology wise, that is a renewable energy used for iron smelting also we observe here. Actually, this iron smelting is around the world there. But there's a wind energy used for iron smelting. We found some evidence in Sri Lanka in the Samalava, but that was a point of view. That is there's 300 before CE. Actually, this is the correlation with that Godavaya harbor. Actually, that also I'm not going to discuss this all technological point of view, just only the concept wise, we can understand how that renewable energy used for this type of high-tech. One, we know that the iron smelting we require high temperature. Then at that time, these people use the biomass. The biomass combustion, we need to generate very high temperature, more than 1,400 Celsius. However, just biomass, it cannot be generate that much of temperature. Then these people may have that technology for uh, uh, produce a char with uh, less oxygen environment. Then the char can be used for that smelting purposes. Then the blow by air by in the Tamil Nadu area, they use the wind energy a long time ago. It's totally renewable energy. It's a concept. Actually, Damascus is the place. That's the point of what I use there. In Sri Lanka, at that time, they generate Damascus steel, the high carbon, medium carbon steel, I think. So they import Damascus. There's ship breaks also at that time. It's a Malawi mouth. The ships from Sri Lanka to Middle East, maybe 3,000 years back. I'm not going to explain those things very deeply. However, this is some technology was there, how people used at that time for renewable energy used for their data requirement. The steel requirement was there, how they use that renewable energy for their requirement, even though medium carbon steel also the produced at that time. Yes, as well as that historical concept, maybe the comfort of their life, maybe then as well as because of that oil also coming from biomass, the heating methods, as well as the cooling methods also, they use the passive cooling system with the solar and the wind, maybe the energy efficient house that was there. No, not only Sri Lanka, this throughout the world, they have depend on the place to place. Then those other renewable energy usage was there at that time before the transition of energy to renewable to fossil fuel. Now, yes, these are the concept what they use here in for lightning as well as all those things. Now, the transition point of here now. Now we already complete that first one, some idea of the renewable, then the historical context of renewable energy. Now we are going to talk about that, what are the renewable to fossil fuel and renewable transition. Then yes, we know that the call begins 1,700. You can see here. There's a coal engine that was a steam engine. That's the biggest the changing point in the world because of that. Actually, with the coal also the high energy intensity the fuel is there because of we can use that coal for thermal energy requirement. We know that the previously people used that the biomass for iron smelting, the difficult pathway. Biomass converted to the char in the high dense fuel. It was a difficult pathway, but out of coal, now it can be convenient to do that again here. Now the cost of energy as well as the attempt is less now. The previously the people need more work, more cost. Again, the cost is there. No, the cost is there. Now it can be done very quickly now with a call. It's a call. It's much easier compared to the renewable energy because of the high dense energy there. Now what happened? There's a renewable energy renewable energy usage, that means the technologies replaced by this type of the fossil fuel step by step. That's the way how it's changed there. The previously it used that renewable energy maybe for transportation. This that steam engine was invented, that thermal energy can be converted to the mechanical energy. Very first, the coal engine, the very first steam engine was used to replace the windmill and water mill. Actually, now this the food preparation is the important point there. Now the people use that steam engine to food preparations very long time. Then later that steam engine used for their transportations. Yes, the motivations for renewable to fossil fuel. Actually, we know that how is always the call to there's a renewable to fossil fuel is an important point. Then it is convenient, cost effective, especially the cost effective. No? Compared to the at that time, maybe the fossil fuel is a cost effective compared to the renewable energy. It requires a large amount of manpower, maybe other preparation processes. We people convert because of the coal and fossil fuels. The fossil fuels are cheaper than some derivatives are there. Now, again, the motivations to the renewable to fossil fuel transition, those are the things I already explained here. The high energy density. Then as the consistent power supply is that also important point. We know that renewable energy is not consistent. It's a natural resources. It vary due to environmental conditions. Then it's very difficult to control also. Then the storage also not much easy. Then the cost of energy wise, we can discuss later. It's depend on the technology. At that time, it is much less. Then it is depend on point of view because the cost is not only for a technology, it's a policy and the political and a lot of things behind there in the cost, as well as the easy to store and the transfer because of again that the energy density. Then a boost of economy of the nations is coming there because of again because of productions and everything can be improved by the fossil fuel. Because of if we required some energy for other productions, the fossil fuel is give some boost there compared to the renewable energy. Other thing is especially when the power station can be built almost everywhere. That is not site specific. The fuel can be bring to place easily. Those are the you can see here comparative advantage of fossil fuel. It cannot be very challenging. Renewable energy can be challenged, cannot be challenged, or some point of view. You can see still these challenges are there. Though those are the motives for transition to the fossil fuel. You can see here. Yeah, actually, these things are the changing point, that is steam engine point. Then it is 1712. It used that new steam engine. There's a commercial steam engine was developed at 1712. You can see here. Then actually steam engine, steam is generated by the coal burning. Again, that the concept was developed here. Thermal to mechanical energy. There's an energy transfer technology. Here that internal combustion engine also next point there because of that internal combustion engine was developed again that's 1860 after some years back from that the steam engine was developed. That the purified fuel can be generated at that time. That the purified fuel can be used for internal combustion engine because internal combustion means combustion is occurred inside some chamber. It required the purified the fuel. The present day we know that petrol or diesel or some sort of purified fuel. Then that internal combustion engine may be very much compact compared to the coal engine because of coal required some of the separate things to do that. Then the very compact the high dense energy engine was developed at that time. We are calling this internal combustion engine. It is the change of our transportation system throughout the world. Then we can see this is the transition times. Again, some sort of the windmill is converted to the coal, or that is stationary steam engines. Now those are the abundant. The wind energy was abundant at that time. Now you can see this transition is very much interesting. Wind energy to the fossil fuel. Now again we are thinking about that the fossil fuel to wind energy. Now this is the transition we are going to discuss today. Again, you can see that is the again long time ago. It was that the same thing. The battery car was operated. You can see it very much long time again. Yes, actually that energy, that's an energy storage technology was there. Then again, because of that, again, due to some other reasons, not only technology, political and other reasons, comparatively, it coming into the world, again, that the battery vehicle, that especially the EV vehicle, was demolished at that time. Yes, that is another concept is there, that was Stirling engine. That was very much important engine in my in my view, because of it is external combustion engine. Here, that external combustion engine mean is not required very much the purified fuel. It only required the heat source here. Actually, this Stirling engine was developed before internal combustion engine. However, people much concerned about, they would give their attention to internal combustion engine. Internal combustion engine was developed, then that developed very well. They neglect that Stirling engine at that time. But I think in the usage wise, Stirling engine is very much useful, because of it. It can be used not purified oil, because of as it is external combustion engine. Now again, that the Stirling engine is coming to, we can think about that, because of the renewable energy sources, especially biomass and other things we can use for Stirling engines, because of it is external combustion engine, as well as the solar. The solar also can be used here, because you can see here, are then heat source there, the heat source and heat sinks. If you can use as a solar energy to heat up that point, that can be used as Stirling engine. You can see here, it work in the Carnot cycle efficiency, because of the Carnot cycle efficiency we know is around 40%. Then it's the highest conversion point of view compared to the solar PV. Still, the solar PV is still behind the 20% conversion efficiency, but in the current cycle we can go up to 40%. That's the reason. Now this technology is using for a satellite to convert solar energy for their fulfill its energy requirement. Then that's Stirling engine concept. There's a transition again. You can see here, there's a transition also coming here. You can see here the base load is the traditional biomass still there. Coal is replaced, some sort of that, as well as the oil, gas, nuclear, and renewable energy. Now, again, we think about that point of view here. Now, what is the situation present day now? Now we are facing other lot of problems. What are the problems? Now we are feeling that the fossil fuel maybe not staying with us for a long time. It will be that resources are limited, because of it's not renewable. It's not renewed, as well as the facing a lot of the environmental challenges are there. Then that assume that we can see here, year maybe 3000, we need to change again. We have to find out some source of some sort of energy sources. Now the challenges again to the fossil fuel to renewable energy transition. We can think about that, how we can replace fossil fuel by using other source of energy. Because the technology need to be developed now. We have a lot of challenges. We need a lot of work to fulfill that requirement. Right, we can see another point of view. Actually, this is day before yesterday. Yes, actually, this is the day before yesterday. These oil prices are there. Oil prices are, there is around maybe sometime the $100, maybe up to the 60, 50 US dollars. That is depend on time to time. You can see here. That is the main parameter for renewable energy transition. If oil prices are very much low, the fossil prices are very much low, then because of the cost of energy, the point of view, the cost of energy, people are not willing to go for a renewable energy. The high cost, actually, renewable, either renewable or fossil fuel is not the matter here. We always seek about the low cost energy, and which is low cost, people think about to go for a low cost energy. Now, this oil price can be controlled. That is the point here. Renewable energy prices cannot be controlled. That's depend on the technology, as depend on the resources. that is depend on that point of view. We need to develop some technology to reduce cost of energy of renewables. There is different challenges there. But the oil price is depend on the policy and politics. Then you can see now that is very much easily controllable. You can see the usage of renewable energy can be controlled by the price of oil. Then that's the point here. Then here, if we think about that, the generation cost, that production cost, the production cost of the crude oil also depend on the place to place. If we go for a Middle East places, the oil barrel production cost is around $20. But in North Sea, little bit high again. The North Sea is a little bit high again. You can see here, even though the production cost is $20, it is more than double. It's a real price there. There is maybe a profit, maybe some other places are there. Here we can drop up to that level here. Then this is challenge here. This is challenge. I don't know. It's challenge or this is thing because of this oil is belong to some sort of countries only. Politically they can control the other source of energy generations. Then this is the energy security also come in here. Then we have to think about that energy point of view. Then if we go for renewables, why we go for renewables? Is it the cost of energy wise or other factors? Yeah, because of energy is the mandatory requirement in the world, so especially maybe production, maybe other things. You can think about that. If we have not electricity today, what is the situation now? If we then that's the things we have to consider now because of energy is not only technology. The huge portion is coming from policy and politics. Now, the transition challenges also, some other transition challenges also there. It is not convenient sometimes. You can see if somebody can compare that the usage friendly, you say still we cannot develop, we can develop, but it's cost wise. Again, we can see the gas and biomass. Gas and biomass for a household cooking, you can see here. Then yes, now the why these people trans to the LPG in the household cooking compared to the biomass, especially then we have to think about these things for a transition point of view. Yes, we can develop some technologies, obviously, no problem, with the renewable energy for comfort cooking, that possibility also there. Again, the cost comparison also we have to think about that. Yes, again, some point here we know that some countries the biogas can be used for their transport. Actually, biogas can be generated in the different sources, especially maybe waste can be used here. The waste can be used in the biological process, the biological pathway, it can be generated. The biogas can be purified then after up to methane and remove some other unnecessary gases. Then the high dense energy can be used for transport up to some level. This is good because of that is double benefit, the waste management as well as the renewable energy sources. If you go for a fossil fuel, there's a point there. Now still, if we need to promote that biogas, we need to give some grant and concessions. Then we have to impose some tax on top of the fossil fuel. This is the way how we can convert that. Then you can see the tax, grant, and concession. This finance is coming there. The country economy is coming there. Then always the economy and energy is intercorrelated. We have to think how we can convert to fossil fuel to renewable or biofuel. Each and every countries they consider these things. Especially I have some case study recently. The Norwegian people, they are much using biogas and other renewables for their transportations, even though they have the fossil fuel. Then there's a policy and politics behind there. We have to think all these things, how we, not only technology, other important factors need to be considered. Yes, now the move to fossil fuel renewables. I already explained they are the why uh, renewable to fossil fuel. Now again, it is again we rethink about that. Actually, you can see there are a lot of things again. Say environment and energy security, especially country like us, um, as well as the healthier the job creations. A lot of things we have to consider if you go for a renewables. Renewable energy, here that a levelized cost of energy, here that a total equation I'm not going to explain here. However, just for your know-how, if we consider its lifetime involvement, what are the cost of energy generation? Actually, the next present value mean the total, if we consider its lifetime cost over its lifetime of any project, if it was solar or wind or any project price, how much of energy is produced. This energy production is depend on the resources, the place to place. Then we can consider how much of the cost per one, the cost per generations. There's a very much important parameter when we compare each source of energy. Because of if we go for an energy source, we have to check that how much of the levelized cost of energy. Shall we think what do you think about that? If the levelized cost of energy of wind is higher than coal, then what your decision like? Then we have to think about that because of we have to we cannot compare only cost of energy. Then then other source we have the foreign currency also there, as well as other point, maybe the price changes. We have to check all those things in the transition point. However, if we compare the levelized cost of energy in here, these things we can discuss in detail later. However, we give just for an idea today. There's some comparisons. These are some comparisons here. Now you can see here actually the present in the Sri Lankan situation. I have not that total data. However, with that the concession wise also the green point, it gives some concession for point of view. However, we can do some comparisons regarding source of energy. You can see here the coal, gas, geothermal, as well as some renewable energy sources also there. What are the levelized cost of energy? One. Actually, that is per megawatt hour generation energy. Actually, the some renewables is much more competitive with conventional fossil fuel. That is good. That is very good. You can see here the wind onshore, wind the solar. We can think about that very much competitive compared to combined gas, as well as the coal. You can see here there is much competitive with respect to USA, but in there's a cost. Again, we need to recalculate by considering locational wise, because that is resources as well as the technology location. Then we have to do cost analysis, so not same throughout the world. Now, you can see here. Actually, the challenges are also there in the when we consider renewable energy, especially for renewable energy. Intermittency is a very much huge challenge present day, as well as the energy storage also required. That also again very much challenge because of the cost wise. Still, that technology is not much the popular, not much developed, the low cost one. Then that's required the grid integration. Then these things. Benefits, obviously, there is environmental benefits is there compared to the other point. The country by Sri Lanka is a foreign currency point of view. Also, we can think about that renewable energy because of maybe capital is coming from other countries. Some sort of we can do some policies for that also. what are the amount of the local contribution. Then same as some other places, they also implemented that type of criteria. Then that foreign currency involvement can be reduced if you go for a renewable energy. The challenges or benefits both are there. Now, the important point, what I can discuss in the present, our day-to-day life pattern, we are in the consumer economy. Still, I can understand how we can give the proper solution for this consumer economic effect to energy. Actually, the consumer economy, due to that consumer economy, our energy consumption is increasing day by day. You can see that's actually that's the per head energy, not only the total energy. That means the single person, the per head energy consumption is increasing each and every day. You can see here, that's a challenge now. The consumption is increasing every day. Actually, it's a good services, and this is we are calling this consumer economy. Not this pattern is we can also throughout the world. Actually, this is data in Sri Lanka. You can see here the data in Sri Lanka. Also, energy usage is increasing day by day. You can see here. Actually, this is the bad point. Our industrial requirement may be almost same, not much change. However, other services may be transport as well as the household and other commercial activities we are increasing. However, the trend is there. This increasing trend is there. It's not only Sri Lanka. This throughout the world that this trend is there. It's per head also it is increasing. Then how we supply this amount of energy? You can see here that also one predictions in that is in the night view of the world in a 2000 view. Then that's a light emission throughout the world. You can see here, as well as the predicted light emission in 2030. You can see here. Actually, you can see here now in the 2000 there are large amount of light emission in the Europe and America. Then in the 2030, you can see here in these countries also they are going to increase their energy consumption, especially in the Asia. That means development. That means the consumer economy is the transfer to Europe to Asia. Then that also one idea. Actually, there is a power requirement is almost double. Then this power requirement almost double. Yes, obviously some sort of the population increasing also there, our per head increasing also there. Now, present day we are calling about the sustainable solution. Actually, in this MSc course also, the circular economy, the point of view, we are going to discuss a lot of things, how we give the sustainable solution. Sustainable solution, to find sustainable solutions for steady state, it can be okay. But we need to give our sustainable solutions for dynamic system because of our demand is increasing. But the solution, we need to give a sustainable solution for dynamic system. It's very difficult. That is very difficult. And we also seek to find dynamic solutions for that case. That means our capacity of that power plant need to be increased. The capacity of the waste management system also need to be increased day by day. Then this dynamic solution also. That means that gap cannot be fulfilled because of the increasing. Then again, we need to that is this ad hoc manner we can observe each and every day. This waste as well as the energy problem is we cannot solve completely due to that consumer economy effect in the world. Then that is my point of view. But we have we need to develop our technology each and every day. The question, this sustainable is that is questionable again. However, now the challenge is there. Now the fossil fuel again. Actually, this increasing trend is there. It's not like that. There's increasing trend is there. We need to fulfill that requirement by the renewables. Can be possible that there is a challenge here now. that requirement is for fossil fuel, the replacement of the fossil fuel. Yes. Energy resources wise is can. Then you can see then very first slides I saw that there are the plenty of energies there. The conversion technologies should be developed to convert to fulfill that requirement. That's the task of uh, technology development. You can see another point here. Another point here. Actually, the renewable energy point, there's intermittency, as because of there is a huge challenge. If you see that's this graph there, you can see the renewable energy supply is very like that. That's variation of renewable energy supply. But our demand and supply cannot be matched completely. If we have the primary sources, like as a fossil fuel, we can control our generation. Yes, but if we are using renewable energy sources, especially like solar and wind, because present day we are going to move to renewables like solar and wind. Hydro power is especially in Sri Lanka, we are already exhausted. We have not much uh, development for hydro power stations. Then we need to think about that solar and wind, not like in Sri Lanka, throughout the world also they are going to move to that area. How this gap, the supply and demand gap is very critical today, because of we know that especially this is one can see one this is one example. I just find out can see the one report can see here. Now there are a lot of curtailment throughout the world. Not the wind and solar curtailment is there. The present day we also a little bit think about. We also very recently in Sri Lankan context also we are discussing that this is a curtailment issue. You can see the curtailment in the Scotland is the 2.3 terawatt hours. It is very much compared to the Sri Lankan situation. Is it is more than our whole requirement, that the curtailment of wind energy. That is not only Scotland, that happening throughout the world there. There's a curtailment issues is coming there, because even though energy is there, it cannot be used here. Then these are the challenges. The technology, this technology need to be developed to harness this all renewable energy. Then because of the peak demand and low demand, gap need to be fulfilled. Yes, energy storage may be a one solution, but still there are a lot of challenges due to cost wise one. Yes, then we can do a lot of research work out of that, how we can reduce that amount of curtailment, wind and solar. Now, the Sri Lanka also presently, the utility is think to do some curtailment of solar. You can see here, these are the challenges presently we have in renewable energy. Actually, storage-wise, there are some technologies still in the pipeline. The hydrogen generation, still we are still in the pipe. Very good option maybe. Then that also we have to think about that EV charging hydrogen, as well as the pump hydro power cycles. Also, we can think about that. If you have any questions, you can discuss further. Yes, this is the one project we recently I found it. In Sri Lanka also we are thinking about the first ever battery water battery display like that. In the CB going to launch a project very recently. They're going to establish by 2030. There's the pump hydro storage one. There's a pump storage one. It requires the two storage system. They propose that now LPT and Aramaic two reservoirs. There's a high reservoir in Navalapiti and the lower reservoir in the Aramaic. It can generate up to 600 megawatt the capacity up to 6 hours time. Just huge. That is huge amount of energy can be stored there. It's a good point. Then if we can establish that plant, we can absorb a large amount of renewable energy without curtailment. There's the point here. However, there's a conversion efficiency also not much bad, the pump hydro one. Then this type of technologies are required to do that. But this also limited. But in Sri Lankan situation, we can manage up to that point. But some countries like Scotland, I don't know how they are going to manage the huge curtailment, like 3.2 terawatt hours, a huge amount compared to us. Still, these things they need to be challenges are there. I think the concept wise, I already discussed a lot of things here now. If somebody have some idea or any questions, we can be discussing very further. Yes, we can have another just 20 minutes time, I think so. You can ask any questions. We can elaborate something. Somebody asked that the CB1, I don't know how can I, what is this one? Oh, they are some tier tariff one. Actually, CB tariff system, I can't explain that because of that's depend on lot of reasons. However, just I give some idea about that in the country, the concept wise. Actually, day and night. Sometimes actually this tier tariff. There are tariffs doing for each and every sources. You can see here. This is the point about that's the thing what I already explained there. Can you remember the very slides I explained about the biogas one? No, if somebody need to promote biogas because of the biogas utilization, maybe it required some double benefit because of the waste. Waste can be utilized because of waste issue. Some countries, if they have the huge waste problem, then if country need to solve that problem, we can give the higher tariff rate for waste to energy. Actually, Sri Lanka also we have that, but I can't. I am not going to comment on that prices and everything. Then if we give that a higher tariff for the waste to energy one, then we can mitigate some sort of the waste management one. These are the things can be considered, these things. Then you can see it from the wind energy or solar energy. I know that some countries, they promote the rooftop the wind energy. Some places, they give the pre-tax as well as a loan scheme for these things. They can do that. Sometimes if we have some energy security point of view, especially you can see, especially present day, I'm not going to large amount of think about the Sri Lankan situations. We also can develop, we can think about that, these things. You can see here, sometimes energy security, especially we noticed that the last few years, the European people, they have a lot of energy security because of the gas line coming from the Russia can be shut down sometime. Then even though the gas is low cost, then there's energy security wise, they need to develop large amount of the offshore wind energy, even though the cost is high. You can see here, there is the point of energy security one. Then now at that point they can give higher tariff for wind energy and to promote wind energy. That is the way the tariff systems is working. That's the way that the tariff systems is working. So not only cost-wise, the policy, the country policy, energy is not only that. There's only the one point. It's bind with other all effects, maybe social, maybe political, maybe other lot of effects are there. The tariffs need to be the tariffs need to be designed based on that. Shall we think similar like that one? Shall we think now our fuel price? The fuel price. If we give the what is our requirement in the country wise? If we want to reduce our fuel consumption, if we want to reduce our, yes, because of the foreign currency involvement is there. Then, but we cannot increase our fuel price because that may be effect to our day-to-day life as well as the production. What should be the optimum fuel price to reduce our foreign currency drain as well as be minimum effective day-to-day life? And that's the pricing. The pricing can be very much controllable one. No, if we increase our price, our consumption is less. Then the pricing and energy pricing is like that. Then economic things are there. And so not only technology and all those things, political, social. Then these things need to be considered. This not only one. The one person cannot be do that. In the technological person cannot be do that. It need some vision of the country. Then it can be divert that can be changed the things throughout the country. You can see if we give low cost energy for production, yes, production can be increased even though then how we can give that low cost energy for this type of industries. Then we have to think about that. I think I don't know that the CB tariff system. I have no idea how they decide that. It's not into my area. Yeah, somebody asked the lower rate for waste energy and biomass. Yeah, compared to other sources. Yeah, that's I would explain that. If we need to solve that waste problem, we need to go higher tariff for waste to energy conversion. That's the point there. But the thing is that presently these organizations are working separately. It's not good. Then we have to give some the one governing body for that fuel, waste, electricity, and all those things can be controlled by the governing body. This policy level one, no? Then we have this idea. I can't give that example. My point of view, if we have the waste problem, if we need to solve that, we need to give some higher tariff, reasonable higher tariff. No, that not need to be burden for utility company. That's the issue today. Actually, today, what's the situation in my view is there. We are not in a stable situation because of we are in the financial crisis. Each and every individual institute try to survive themselves. Then those effects are there because of their strength is not much high to bear some losses. Then this is the maybe a situation that this is not the normal situation. This situation is not normal. Then very critical situation without doing any huge damage for each and every institute, we can do these things. Because of treasury also cannot be give a lot of money to survive them because of they also not have any money. They maybe. However, the tariff system is important to promote any source of energy as well as if we want to demote some energy sources. If we want to demote some utilization, we can give higher price for that. That's the only way how we can do that. The other things, the tier tariff also very much important. Still, we are not using there because we have not the smart meters and these things because of we can do some tier tariff day and night two tariff systems as well as the battery charging vehicles And all those things we have to consider very critically in the Sri Lankan situations. If somebody have idea, no problem, because of maybe you may have a lot of idea and knowledge like that. You can contribute. Actually, these type of sessions we can see here, very first day, you can remember Professor Torsten also explaining the present time. The teaching is not the important one. The learning is the point here now. We are going to promote to a learning rather than teaching. You need to gain your knowledge yourself by learning rather than teaching. Teaching is useless in the present time. Some use some the chat box. Please wait. It may be difficult to read some of this. Explain about wind power curtain. Yes, shall I try to explain one by one? The wind power curtailment. Yes, there are some questions in the chat box. Please wait. The wind power curtailment. Actually, in Sri Lanka, the presently it not much doing the wind power curtailment, but in the some countries they are doing that because of the grid is not ability to absorb that wind energy because of that stability point. They are going to shut down their wind power plant. They are not ready to absorb that power by the wind power. Then even though the wind resources are there, wind farm can ability to generate power. It cannot be feed into the grid. There's a wind power curtailment. Then resources is there, plant is ready to generate, but grid is not absorb that power. But then there may be a possibility to doing that curtailment in the future. You can see here, because of if we're going to establish large amount of wind power plant in Sri Lanka, our grid pattern, our demand also is not, if it is not matching the resources, we also need to do some curtailment. But that precautions are there. If we're going to establish our pump hydro storage as well as the connected with the India, that the possibility can be reduced. There's a point here.
Sir.
Yes, please, if you can ask, no problem.
Decentralized energy systems is a solution for that one, for the stop the curtailment.
Yes, up to some level now, smart grid we decentralize. Yes, up to some level. There's different technology. Decentralized one is there. But now that energy storage and yes.
Energy storage, sir, is it possible to generate hydrogen in that community level to store the energy?
Yeah. Presently, the technology is there. Generate hydrogen. There's green hydrogen generated by the solar and wind. Technology is there. But I noticed that it's still not much commercialized, because the reason is that it's still the cost and everything is not much friendly. It looked like for me. Actually, one idea, one of my students presently working in the hydrogen train in Italy. Now they operated a few times that they stopped that now again because of that cost-wise is not much, it's still not effective. However, I'm not saying it's not, maybe growing very soon. Now, rather than curtailment, generation hydrogen and operating is still some challenges are there. still some challenges for large scale. Maybe that will develop very soon because of the all over the world, people are thinking about the green hydrogen, everything. Actually, there are a lot of the pathways also. If we can generate green hydrogen, some countries are willing to purchase that, especially in some Asian countries. I hope that technology will develop very soon. Then we can think about that when converting to the all over the renewable energy. The hydrogen technology will develop soon. Decentralized hydrogen production also may be possible. Actually, in Sri Lanka also they have some plans there. Then we have a lot of the offshore wind energy. Then offshore wind energy may not going to be connected to the grid. They totally separate to generate hydrogen and produce a green hydrogen. That may be one point of the hydrogen is not only for energy, it can be very much useful material for other productions, maybe the fertilizer and other things.
Sir,
That
how about
possibilities.
the ammonia production? The last
Yes,
few days,
yes,
I have heard that
yes,
Toyota
yes.
is generating an engine for
Yes,
engine
yes,
suit.
ammonia. That was a good point. Actually, the comparatively hydrogen storage, the ammonia storage is much more comfortable. That means the pressure wise as well as the penetration. I do know that the hydrogen can be penetrated throughout the steel also. Actually, I can remember we also did some project. Even though 1 inch steel wall, throughout that wall, the hydrogen can penetrate. But ammonia is not like that. Yeah, the ammonia is one of the fuel can be used now because of its a carbon. It also ammonia also not carbon-based fuel converted to ammonia because the nitrogen is freely available throughout the world. Hydrogen plus nitrogen is converted to ammonia. That technology also there. Yes, that possibility. There are a lot of pathway.
So if we use the ammonia, then the byproducts will be a nitrogen dioxide or
Yeah,
something like that.
that was some issue. The NOx problem is there. The
Mm.
NOx issues is there because that generates some sort of NOx again. Then
It will
again we
be
can do some iterations.
yeah, it
We
will
can
be
do some
recycled so that
iterations.
acid rains or something.
Yes,
Uh,
actually NOx also issue here. Then as a combustion of ammonia, we need to do some other precautions for NOx emissions.
if
That
we
is the issue.
generate if we generate the ammonia, so what is the process? It will be
Herb process, no? Herb process, no? Can you remember? There's some processes there. Chemical name I can't remember. There's a chemical processes there. Nitrogen and hydrogen. We can combine together. Actually, but
uh,
it's one part of there's one part of the urea production.
for that that ammonia production, it will be used that atmospheric nitrogen or
Yes, yes. It use atmospheric nitrogen. In the Sri Lanka also, we had this type of plant in the fertilizer corporation. They use the hydrogen from at that time they use the hydrogen from our refinery. Then nitrogen by normal atmosphere. Then they produce ammonia. Then after convert into the urea.
okay, sir, thank you.
We
Thank you.
had that plant in the long time ago.
Yeah.
The same process now. That technology maybe some sort of improvements are there. How we can convert to the urea or NH3.
Okay. Thank you, sir.
There are some. Yeah, somebody asked that LMS lectures maybe materials. Yes, almost sufficient, as well as you can follow some of the discussions things also. CBRs to domestic solar-based energy storing reservoir hydrogen. Yeah, this I already explained that because of the CB presently in the maybe some issues in their stability due to the daytime because of that coal power plant cannot be derated too much. Then the base load plant. Then if we feed a lot of amount of solar, actually the CB also cannot assess how much of solar can be generated because of the rooftop solar. then they try to do some of the storage system, especially now. Actually, there's some plan is there. You display and there in the now Haranayaka Mahawaya hydro storage system may be going to be, they be going to 600 megawatt capacity one they going to establish in 2030. If it will be established, this lot of problem can be solved. This way having the enough renewable energy resources being right. Serious. Yes, we have the fossil fuel. Yes, that also one point here that you can see the fossil. We have not a fossil fuel. If we can convert, if we go for a wind and solar, yes, we can think about that. But the point is there, we have to think about a little bit the cost of energy wise. We have to recalculate what are the cost of energy of solar, what are the cost of energy of wind, what are the cost of energy of coal, what are the cost of energy gas. Then we have to think of energy security, foreign currency involvement, then all things need to be considered to transition point here. Not only cost of energy, not only environment, then a lot of things need to be considered to transition to renewable energy. It is very difficult point. Then actually the energy is not only technology, not only environment. Then the huge portion is coming from socio-economic as well as the political. Yes, again, somebody asked that the grid stability issue. Yes, I hope that the technology will develop that a pump hydro one that will can be solved there. It can absorb large amount of wind and solar. Yes, obviously. If I give all answer for these all questions, if I miss that, please ask that verbally. That is convenient to me. Actually, that stability point is coming there. Demand and supply is not match. In the energy is there is a power. Actually, it's energy and power is two terms. No, actually now the power we are using there. And that mean when we using that some energy, the same time it need to be generated. If we have not any storage system, presently we have not any storage system for our grid, then at instantaneously we need to generate what we consume here. Then what happened? We have a sort of generation, especially hydro, coal, and some other renewables like solar and wind presently. Now, unfortunately, presently our base load is coming from the coal. The coal, the technology of the coal is it cannot be derated too much because of it has a lot of thermal energy as well as it cannot be derated quickly. Then that's the point. That is the point there. If our demand is less, very much less, then sometime we need to shut down our low-cost hydro by keeping our high-cost coal. That happening presently. Sometime in the night time, the 3 p.m., 2 p.m., we are firing coal by shut down our low-cost hydro power because of we cannot deteriorate. The reason is we cannot deteriorate the coal. Similar things it may happen in the daytime again. If we have the high amount of solar penetration again, that issues will come there. That's the things they are explaining recently in our CB people. Then if we have the storage, if we have a good storage one, that's not the point. There we can store that excess air, that means low cost energy at that off-peak time, and utilize that off-peak energy in the peak time. Then there's the point they are going to plan that pump hydro system very soon. Again, we have to think about all the cost involvement and everything. There's a challenge of renewable energy throughout the world. I hope I give answer for this all questions, right? If you have not any questions, I can wind up the sessions today. Right? Okay. Okay. Thank you very much. All.
Thank you, sir.
Thank you, sir.
Thank you, sir.